All right, now we're going to talk about compositions of functions, which is a whole brand new operation. It's an operation you have never done before. So a composite function is the result of applying the rule for one function to the rule of another function. So the new rule is denoted as f with an open circle g. Okay, so this is not fog. My students always want to read this as fog. It's not fog. It's an open circle instead of a closed circle like times. Okay, so times would look something like, times would look something like this, f times g. That's an open circle, okay? Or we can write it with parentheses, and I, again, prefer the second notation just because it makes more sense to my brain, that we are plugging g into f. That's what's happening. You're plugging one function into another. Okay, and that operation is called a composition of functions. So we're going to start by looking at, again, a table and a graph to kind of see what things are doing numerically, and then we'll apply them to a function. So we're going to use the table to find f of g of x. So f composed with g of x is how this is written. So f composed with g of 4. So when we write this, we're going to say f, I'm going to rechange this into that second notation. So of g of 4. And we write it in the same order that you can see right there, f with a little circle g, f parentheses g. Now what this tells me to do is the first thing I have to do is I've got to find g of 4. So remember, the 4 is the x. I need to find the g value. The g value when x is 4 is -1. So that means g of 4 is -1. We are then going to replace the g of 4 function with that -1. g of 4 is -1. And what we're going to do is now this is our new x for f. So if I go to the x value for x, so right here x is -1, and I go to the f value, f of -1 is -2. So what we've done is we've plugged a number into g, got an output, and plugged that into f. This right here went in to go up to get that value right there. So it's a little bit weird, but that is what we're doing. We are plugging in a function, getting a value out, and then plugging that value in to get another value. It's kind of like a chain. Okay, it's like you start here and then go to another one. Okay, what if we look at the graph? G of f of -1. So again, g of f of -1. So that -1 is an x value. So we go to where the f function is -1. So that f function is right here. So that value, f of -1, is 0. That's the y value, 0. So we plug 0 into g. We replace f of -1 with 0. We say, okay, what is g of 0? Well, go to the g function and find where x is 0. That's right there, the value. That's also going to equal -2. So we would say that g of f of -1 equals -2. Now the order does matter. Okay, whether you're plugging f into g or g into f, it matters. So you have to know which one's going in first. Okay, so this one we had to find f first and then plug it into g to get the g value. Now, what if we have just new functions? We don't want a number, we want a new function. Well, we can do the same thing. So what if we want to find f, let's see, what did I do? Actually, we're going to do h, I think. So let's do h of f of x. So this time I'm going to give it to you in the function I like. So h of f of x. So what this means is we are going to we have two functions we need to know. We need to know that we have the f, okay, so the f function right here is x squared minus 3x plus 5. And we have the h function, which is 2x minus 3. Here's what we're going to do. We are plugging f into h. So we're going to take the f function right here, and we are going to plug it wherever there is an x. We're going to replace the x with x squared minus 3x plus 5. So here's what this is going to look like. The f function is x squared minus 3x plus 5. That is the f function. we are plugging it into the h function. So when we have this, we're going to have 2 times that entire expression, x squared minus 3x plus 5, goes in for that x. Okay, that's the x value. That is now the x minus 3. Otherwise, this expression right here looks exactly the same. 2 times my new x minus 3. And then we're going to simplify this down. So to simplify this down, we're going to distribute. So 2x squared minus 6x plus 10, and then minus 3, which means that h of f of x equals 2x squared minus 6x. Now we can add these together, so plus 7. So we have a new quadratic for our new function. What if we had something like g, let's actually use the other function notation, so g composed with h of x. So again, I like to start by saying g of h of x, g's first, so g's first, then h. Go up and find the g function, the h function. So up here, the h function is 2x minus 3. So instead of having h of x, I'm going to put x minus 3. And what I'm going to do is I'm going to take and plug this entire expression into that x cubed, because g of x is x cubed. So instead of having x cubed here, okay, what we're going to have is we're going to replace the x and we're going to put in 2x minus 3. We are simply plugging in one function into the other. So h of x again is 2x minus 3. G of x is x cubed. You are taking this function right here and you are plugging it in right there for x. You're replacing it all together. Now, what is this going to equal? Well, first of all, what does a cube mean? To cube something means to write it 3 times, because we do need to multiply this out. Now, when it comes to polynomial multiplication, you can only multiply 2 things at a time. So, pick 2. I'm going to pick the second 2, but it really doesn't matter which 2 you pick, they're the same. So I'm going to rewrite the first one, and because there's only 2 and 2 terms, that's 4 terms, I'm just going to distribute. So that's going to be 4x squared minus 6x minus 6x. I am going to simplify it down before I multiply more, because I really don't want to have 2 times 8 terms. I'd rather have 6. So if I go ahead and combine these middle terms that are alike, it'll save me some time on what I'm multiplying. So now at this point, I want you to pause the video and try multiplying this out yourself, seeing what you get. Okay, hopefully you are ready to begin. So you should have gotten these values, and you're kind of going to notice that I'm doing it a little bit differently than some of the other times I've multiplied, and I'm actually stacking things on top of each other. Again, this is just kind of a trick. Instead of doing the table, it allows me to be able to add like terms as I go. So hopefully I have gotten this right. Hopefully you've gotten this right. And this is our new function, and it's kind of a big function. Okay, so this would be our cubic that we created by plugging a linear into a cubic.